Hi, I hope that by now you already know how to identify your limiting reactants or limiting reagent and your excess reactant or excess reagent in the reaction. Always remember that when we're dealing with LR and ER calculations, you would notice that in the problem you will be given two or it can be more than two values of the amounts of the reactants, and then there you can figure out by doing the accurate stoichiometry calculations on comparing the amount of the certain product, one product that you will focus on, and then that particular reactant that produces the lesser amount of product is the limiting reactant, and the other one is supposed to be the excess reactant that is not fully consumed in the reaction. Now, we anchor on that particular knowledge on identifying LR and ER to our next topic in connection with that, to what we call the percent yield. Now, what is really percent yield? Now, you know for a fact that when you have a chemical reaction, you can't really expect that your reaction will really be so ideal that it will reach as what you expected it to be. When we perform stoichiometry calculations, our expectation there is that we did not consider other factors that may hinder, limit, or might hinder some of the chemical reactions to progress. We know that in reality there are some factors or limitations that will not really give us 100% the amount of products that we want to get. So what we're doing in our stoichiometry calculation is just getting what we call the theoretical yield. Theoretical yield is the amount of the product that you really expected if you generate 100% of your reactants to fully be consumed in the chemical reaction. But on the other hand, in reality, you know that it's not going to be that ideal. It's not going to be 100%. In reality, there's what we call the actual yield. That's really the actual amount that you get when you perform the chemical reaction. So that's the actual amount that you measure, and that's what you really get, which is, as expected, the actual yield has to be lesser in amount compared to your theoretical yield. So combining these two yields, the theoretical and actual yield, we can get an idea about the percent yield. So the percent yield will give us an idea whether our chemical reaction, whether our procedures are effective or not in generating the highest possible percentage of the products that we want to get. So please remember that in getting percent yield, it's always the dividing of the actual yield over the theoretical yield. Then you multiply it by 100%. Now, for this video, I'm going to show you one problem in which we will be combining limiting reactants and excess reactant, and then we will calculate percent yield based on that reaction. Let's start with this. Okay, this is the reaction of aluminum chloride here. So you see that you have 2Al plus 3 chlorine gas producing 2 moles of aluminum chloride. That's your product. And you've noticed that your chemical equation is already balanced. So we don't have a problem anymore with regards to balancing our chemical equation. So that means we can start. Let's read our problem first. We have 10 grams of aluminum that react with 35 grams of chlorine gas, producing your aluminum chloride. Letter A, we have to tell in the problem what is really the limiting reactant and what is the excess reactant. And then to be followed by letter B, how much is the amount of aluminum chloride produced in the reaction. Now, letter B, I want you to take note of that. You're being asked for the amount of aluminum chloride produced in the reaction. That means you have to get the theoretical yield. But you would expect that in letter A, you'll have two amounts of aluminum chloride, and you would guess that the one that produces the lesser amount of aluminum chloride will be, or the lesser amount of aluminum chloride will be the amount that we will put in letter B. So in letter A's computation, when we identify LR and ER, we will just go to the direct conversion from the masses given to the mass of aluminum chloride. That's the product that we will focus on because that is what's being asked in letter B. So we would expect that this calculation will involve a mass to mass calculation because in letter B, we are asked for the amount of aluminum chloride. And then that will lead us to part C, that if you're given the actual amount of aluminum chloride to be 35.0 grams, which is really the actual yield, then we can get the percent yield, right? So let's proceed by showing that to you. So let me put the space. So let's start with letter A. You know that to get LR and ER, we need to have two calculations. So let's start with the 10 grams. So we have our 10.0 grams of AL. And then because this is a mass conversion, we'll start with the molar mass of AL, which is 27.0 grams AL in every 1 mole of AL. Then to be followed by the molar mole ratio between Al and aluminum chloride, which is, if you look at it, it's 2 is to 2. So we'll put it there. So 2 moles of Al for every 2 moles of aluminum chloride AlCl3. Sorry for that. Okay, then to be followed by the molar mass of AlCl3. Putting that in the calculator, we would see, or we would be able to get 133.5 grams of AlCl3, Cl3, over 1 mole AlCl3. So in this case, we cancel out moles AlCl3, mole Al, then grams Al. Let us just input that together later. Let's input the second given, the second reactant, which is 35.0 grams of Cl2, Cl2. So times, you have Cl2 is 2 chlorine, so that is 35.45 times 2, so you get 70.9 grams of Cl2 for every 1 mole of Cl2. Then the mole ratio between Cl2 and AlCl3 is 3 is to 2, so we put 3 below, 3 moles Cl2, and then 2 moles AlCl3. And then we multiply it lastly by the molar mass of AlCl3, which we can copy from above because we're focusing on just one product, AlCl3, for every 1 mole of AlCl3. So we cancel out mole AlCl3, mole Cl2, gram Cl2. So in this particular computation, I think these are all accurate already. Then we're ready to input this in the calculator. Take note that if there are plenty of numbers on top and on the denominator, always input them once in the calculator by using the parentheses function, grouping the numerator together, press divide, then another group for the denominator, and then voila, you will be getting the answer. So, inputting the 2 in the calculator, we would get for 10 grams of Al, we will be getting 49.44 grams of AlCl3. While in the 35.0 grams Cl2, we have 43.94 grams. Now let us answer letter A, which is our ER and which is our LR. So the one that generates the smaller amount of product will be our ER. So 43.94 grams is the one lesser amount. So therefore, our ER is Cl2. Our LR is Cl2. So our limiting reactant is Cl2 and our ER is aluminum. So ER means not all the 10 grams of aluminum will be consumed in the reaction. So we're able to answer letter A. Now we can go to letter B. It says that how much is the amount of aluminum chloride produced in the reaction? So obviously, if this is the lesser amount of aluminum chloride, so that means this is our amount of aluminum chloride produced because it's being limited by your chlorine gas. So we would expect that 43.94 grams is the amount of AlCl3 that will be produced in the reaction, not the 49.4 because it's higher in amount. So this is the answer for letter A. And this is the answer for letter B. And so, if we know that this is our theoretical yield for aluminum chloride, then we're ready to calculate for the percent yield, letter C. So, percent yield, you know that percent yield is equal to actual yield over theoretical yield times 100. So let us put them. What is our actual yield? It's given in the problem. It is 35.0 grams over our theoretical yield. We just got that. That's 43.94 grams. Cancel out the gram. We cancel out the gram and then we multiply this by 100. Again, sorry for that. There's something going on with the internet. Let's just wait for it to synchronize. But if you look at the screen, you see that you have 35 grams of your actual yield, and then you have 43.94 grams in your theoretical yield, which we got from letter B. Then we multiply that by 100. Oh, by the way, the grams will cancel out. No unit anymore. So 35 divided by 43.94. Our percent yield in this case, expressed into two decimal places, is 79.65%. So that's our final answer for percent yield. So always remember, AY, actual yield, should be smaller. The one mentioned in the problem should be smaller compared to what you get in the computation, which is your theoretical yield. So basically, that's it for our computations of percent yield from the knowledge about limiting reactant and excess reactant. So LR and ER identification in the previous video, we just had the mole to mole conversion because anyway, you were just being asked for the LR and ER. But in this case, in this problem, LR and ER has an extension. The extension would be the percent yield. So in the percent yield, you would need your theoretical yield in mass, in grams. So therefore, you need to extend your computation, your conversion from the given to the mass value. So in this case, our given were in grams. So therefore, I have to start with grams, which is mass. And I have to end up with mass also because it's needed in the percent yield computation. But in the previous video, in which percent yield wasn't part yet, just identifying ER and LR, so that means you can just stop until mole. But in this case, it's a different situation because there's a series of things that you need in order for you to solve for percent yield. So let me end up with this, with some points to note and mistakes to avoid. So remember that limiting and excess reactant computation will always involve two or more given amounts of the reactants. You would notice that in the problem. So that's your hint whether you're doing LR and ER or just a basic stoichiometric calculation. In the basic stoichiometric calculation, you were just given one value of any of the substances, while if you have ER and LR, you're given two or more substances, particularly the reactants. Second, when you determine the LR and ER, focus your stoichiometric calculation on one product, most especially the product that is being asked in the problem, just like what we did a while ago. And then after identifying your LR and ER, then you can determine your theoretical yield, which is always the smaller or the smallest value if there are more than two values. So the smaller, the smallest value, because it's being limited by your limiting reactant. And lastly, to get the percent yield, always divide your actual yield, which is smaller in value, by your theoretical yield, higher in value, before you multiply the quotient by 100. Mistakes to avoid: do not ever forget to identify your LR and ER first before proceeding to solving your percent yield. That is, if in the problem you're given more than one values of your reactants. And then don't switch your theoretical yield and actual yield. The theoretical yield will always come from your computations, your stoichiometry calculations, while your actual yield will always be mentioned in the problem. Take note of these mistakes and take notes of the points to note. So, the moment you will be done watching this video, I urge you to please make your own notes in your notebook, and please apply this learning in your problems in your chemistry textbook. You really need to practice some more so that you can get the hang of it, and you will be able to, to clarify some of the misconceptions or some of the things that you have not learned yet, and then you can ask more questions from your teacher. So this is it for now. Thank you so much. I hope you've learned something. I hope this will enlighten you a bit. And watch for the next video in which we will continue with our excess reactants. This has been Madam Narca saying, don't stop learning, relearning, and unlearning. God bless you. Bye.